Welcome to my short tutorial on the use of RAM concept, which is a structural engineering design finite element analysis software, primarily for the use of designing structural slab elements. So all in reinforced concrete typically, and it's usually quite a scary software for people to be greeted with, as a very unfriendly user interface, I'd say, and that puts a lot of people off. However, it's possibly one of the most useful tools to have in your tool belt when it comes to design of slabs, anything with particularly complicated geometries and complex shapes, levels and openings, and all the wonderful things that these modern flat slabs and such can be greeted with. This is the software for designing those sorts of things. I don't really know how else to go about that in the modern era. But yeah, it's very useful. So, starting then, I would just address what you're greeted with. Unlike most FE softwares, typically you'd have a open drawing block, I guess, where you'd sketch and place nodes, and it has a set axes and all the such. In this it doesn't. It has plans because it's all 2D with, I guess, a 3D understanding of what you're modelling, but it's all on 2D plans, and there's many different sort of folders that you place information within, and within each of these has plans and I guess data sheets that you fill out for specifying load cases and load combinations and such. But just starting at the beginning then, I guess we'll go with drawing import, and you click on the standard plan and you agree with this page. This is your first window that you'd open. This is very useful to take this approach of starting with a drawing import, because what you can do within this space is bring a template in from something like AutoCAD, which is what I usually do, and it makes it a hell of a lot easier when you come to the mesh stage, which is where you'll actually model the elements that you're actually looking to analyze. This saves a lot of time, so I'd highly recommend that. In order to get this CAD template in the first, then what you want to do is come up to File, Import Drawing. I've got one here in my downloads for a pad that I've done recently, and just as an example, and there you go, it's within this space now, and this will be set to exactly what you're seeing here for the rest of the project. This is the only tab that you can edit in, this drawing import section, and if you go over here on the right here, you've got your options for selecting, filtering, panning, copying, scaling, rotating, mirroring, and such, and then at the bottom you have your construction lines, dimensions, and text. There is actually a way within the import to specify scale and the search and the units that you're using. Sometimes I've come across errors when importing CAD drawings based on the units. You have to make sure that the units are correct. If you were working with millimeters, import millimeters, that sort of thing. Just, it's worth giving it a check when you come in, just to draw a line across and make sure what's on there is exactly what you have already dimensioned on your CAD drawing. Following that then, that's fixed into place. I guess I'll actually just talk about the top here, the top toolbar. This is where most of the action happens as you go down the line then. So obviously most people know what these two are. This is something called generating mesh. You click on this once you've got your objects in, and that will actually mesh the slab out. These are further for doing when you get towards the design strips, which is at a much later state. That's if you're doing post-stress tendons and such. polylines. These two, very useful, well, necessary. Calc all and partial calc. Partial calc is there if you want to save time. It will only do a certain amount of the process. But as you get further down the line, if you've filled all your load cases in, you've modelled your objects in correctly, and you've done the design strip stage, once you do press one of these options, it will go through and analyse everything. I'm not too sure about either one of these all that much, but then again, these three are what I use most as well. Within this icon here is the visibility option, sorry. And if you click on this, for each one of these folders, it will have a folder here, a tab actually. And this is very useful because it means that when you're within one of these other folders, you can actually view information from one of the previous ones, which, bearing in mind that this is a template that we want to use as a stencil for the rest of the project, this is where you'll actually end up importing that in later on. Appearance, this is more to do with the general look of the backdrop and that sort of thing. That's a pretty typical sort of option that you have in FE softwares. And then plotting. Once you get to the analysis stage, this becomes very useful. You can go through your different load cases, and I haven't really used this that much, but you can model it then, you can plot it even as a slab, and that slab forces, reactions, strip forces, shear bending, blah blah blah. I'll show you all that as we get on with it. These are two very useful things as well. If you want to increase the text, reduce the text, it's not shown on this, but nonetheless. Moving on. Okay, close this one, move on to the mesh. Open this plan here. And as I was just saying with the visibility options, very important now. If you want to see the template, then you have to highlight it within the DWG folder. Bring it over, there you go, agree with it. And since for this particular example, this is just a pad, I'm just going to draw a slab over the top of that. Just a quick one then. So this is for a wall element. These have been added in now because we're in the mesh section. Wall element, if you double click on any of these, it will come up with the properties. You can give it a name, obviously the grade of concrete, the height for a wall, that's going away from the page into the page. You can set where the support is at, whether it's, actually that would be whether it's into the page or away from the page, I believe. So it's thickness, and then the restraint types for it. And obviously if it's a shear wall, then that changes how the load's going to travel through it. So if I just model then a slab quickly, so if I put it to C3240, thickness of 200mm, priorities are something that will become, well, they are a necessary part of modeling in RAN concept. Basically, if you have two overlapping elements and the software wants to know how to mesh the slab, or well, these elements as they overlap, depending on which priority has been assigned to which element, that will tell RAM whether it wants to model that first or last. That can become very tricky if you're, say, modeling downstand beams or orb stands as well, or steps and slabs where, say for the downstand beam, if you model the priority possibly back to front, you could end up with, instead of the slab being modelled as the flange of the beam, you could end up with a situation where the downstand is just the only area of the beam that's being utilised and the slab is completely ignored, i.e. you end up with a downstand beam that has no flange and therefore is extremely underutilised. Anyway, up at the top here, we've got snap sends, intersection, node, endpoints, midpoints, nearest, that's obviously if you're going along the line, perpendicular, no orthogonal even, so that keeps it going in, X and Y, and perpendicular, we're going to take that orthogonal off, and then center, etc, etc. So simply modeling this then, just grab a corner, corner. This is very rough and not that accurate as I'm just skimming through it. In reality, you do have to be very careful, because half the time when I'm doing this I end up going around having to manually grab hold of nodes and move them to the points that they're actually supposed to be at. Because if they're not bang on in this software, it will spit errors out left, right and centre and ruin the analysis, and you'll get huge peaks in moments where you're not supposed to have them and forces all over the shop. It's just not good. Okay, so we've got that modelled now, which means if we then use this, what I was on about earlier, the generate mesh option, it'll ask us how we want the element size. I'm going to leave it as is, and just generate that. I believe it's done what I asked it to. Didn't come up with anything, but that's fine. So if we now go into this element tab, this will tell us if it's been modeled actually, because if we go into structural summary perspective, then it gives us a 3D model of what it looks like, and down the right here you can move around with it, and well, that's basically what you can do, or you can change the visibility and such. But it's just good as a little sanity check to see if what you've modelled on 2D is actually what you were intending to model on 2D. Jolly good. So actually, before I forget, obviously it's finite element software, so you do have to include supports. Since I don't really have any columns in this case, I'm gonna go with an area spring. And I'm gonna give it something like, I don't know, 100 newtons per millimeter cubed there, and I'm just gonna place that across here. I don't know if they've actually, if that's met the corners or not. It's probably slightly off. Again, this is just best practice to get everything completely lined up, otherwise it will cause errors. Sweet, so now we have our element and the support conditions. That's the first part of any finite element analysis, of course. Moving on then, close this, and close this, and we'll go on to the loadings. So, inside RAM, whenever you open up a new file, it'll ask you which design codes it wants you to, it's asking you which design codes you want it to design to, and based on that it'll try and guide you towards certain things. And so for EC2, it automatically populates this loadings folder with these different types of loads. This isn't something that I've done, these always come with it. I usually delete most of them and then try and rearrange it a bit to make it something that I want to put out there, but the same with the load combinations. Based on Eurocodes, it will automatically populate this table with a lot of load combinations. So within this then, for this sake, I'm going to go and add a live load. And here's our element. Because we generate the mesh, it's carried over. If you didn't generate the mesh, it wouldn't have appeared here. And again, this is slightly changed, and we now have point loads, line loads, perimeter loads, yep, area loads, and then these are just to show moment distribution, distribution plots effectively for later on. If you were trying to just get an understanding of what the live load was telling you, for example, you might use these. So we're gonna just, I I don't know, put an area load in there. I'm not going to name anything, just going to call it that. This is the interesting part actually. I can't remember whether it's, you'd have to put a minus in or not in this. I'm going to leave it as positive, and we'll soon see if it's necessary to put a minus there or not. So again, need to put snap settings on, and if I just put a 2 kPa area load over the entire base of this foundation, and then say if I put a double click that again to get the properties up, if I put a 1 kilonewton load, will that highlight the middle? Stick it right in the middle there, sweet. Okay, so we have our loads there, and another load, if I just place within here, say a line load across this section of 1 kilonewton per meter, sweet. And then if I close these tabs here and I exit out of these 2 tabs, then I will, instead of doing this actually, I will change the loadings and load combinations, because as I've said, there are quite a lot in here, and it all becomes a bit hard to manage as you're progressing through your design. So I will show you up here, okay, within the criteria menu, this is where you will be able to say assign material properties if you have any custom properties to add. This is sometimes where I've seen some people will try and simulate steel by basically giving effective E values for the concrete as to represent steel in some capacity. Obviously not extremely accurate, but this is where all the properties of the materials are tied. So in line with that as well, this is where the loadings are, and this is where you can add or remove loadings. I'm going to remove most of them, so if I go to delete loadings, I don't want any temporary construction loadings. I do want other dead, I do want my live one that I've added, but I'm probably just going to remove the rest of these. If I delete all of those, you see they've removed, that's great. Moving on. And then if we carry on again to load combinations, and as you can see, all of these ones are in here, they've just picked everything out of the codes, but for this particular case we don't need all of that really, so maybe I'll leave all dead in there. There are some that you cannot remove, I might accidentally be clicking on them, but for this case, which one should we leave in here? Actually, you know what, I'm just going to get rid of all of them because I can't read all of that. See, there's some of them that you can't get rid of, but I'm going to simply make some rather basic ones. I'm going to call this SLS. And whenever you make a load combination, you have to specify what the plans is to export are going to show. So because this is SLS, I'll be looking for the deflections and potentially the reactions as well. So I'm going to click both these. Oh, and soil bearing actually as well. So if you click that, and it appears down here, and within this you can choose which rules to set, and this helps when you go to design within these other menus later down, the design status menus later on. Code minimum design, initial service, characteristic service design, and it automatically calculates the self weight loading, so I'm going to put that in as 1. Other dead loading, I'm going to put that in as 1 as well, because that's in there, and then our live load, I'm going to place that in as 1. So on top of that then, I'm going to add a ULS. And again, I don't want deflections this time, but I will take reactions and soil bearing, slab force and slab stress. And that's going to appear down here. And now we're going to do this for strength design, ductility, and anything else? No. So self dead loading, put 1.35 because I'm in the UK and that's a dead load factor that we applied to that over here. Other dead loading, again 1.35. For the live load we're going to go 1.5. And that's how you set up load combinations. So if we close this again and we return to our folder structure, most of them have disappeared. Ours are still there though, that was just placed in load combinations, and that's the ones we got. Wicked, that's great. So now before we can do the full analysis of our design, we have to place reinforcement within it and design strips. This is where it gets quite complicated. You could, however, if you were just looking to do a basic analysis of the loads being distributed throughout the model, the element, you could come up here to either one of these. I usually always use partial just because, due to the fact that things have changed, I need to generate the mesh again, that's fine. So when you click on these calculation options, it comes up with a menu like this, and it gives you these 4 options. So depending on what level of complexity you're looking for, depends on which one of these you are looking to click on. So because I haven't modeled any of the design strips or any of the reinforcement, it doesn't have the information for these last 3. However, you can do a basic analysis. It will tell you how the forces are moving around the object, and you can then use that to influence whatever design you're looking for. So for very basic design checks, this is quite useful. Unless I particularly see that there's going to be huge errors, I usually put this on. Don't interrupt for warnings, because it will just keep iterating through and telling you which warnings approach, but it will tell you that at the end. So if I just do that now, okay, error while trying to calculate internal unstable structure. Okay, well that's probably to do with the pin conditions. Has it actually given us anything though to go off? So if I click on one of these plans under the load combinations, yes, so it hasn't been able to run because of an error with our mesh. So if I quickly just look through this, make sure everything's lined up. Actually, it could be the fact that, yes, I do believe it could be that it's in actual fact that these are supposed to be negative, that effectively the pad is being lifted out of the ground by these loads. So as I just did then, if you just right click while something is highlighted, select properties, you can get up whatever properties, whatever you're clicking. So if we then change these to minus numbers, obviously it's going the opposite direction then, isn't it? And if we go through and rerun it, hopefully that will have fixed the problems. So area load, change that to -2. Point load, change that to -1. Okay, wicked. So if we now close these then, fingers crossed, if we run this again, okay, it's not playing games, playing ball with us. Okay, well that's a bit upsetting. If I just remove this instead and just put pins in, could be my saving grace. If I just put pins at the corners here. Then perhaps that might be enough. So this from creating these errors. If I generate the mesh again and run the analysis. Oh, what's going on here then? Unstable structure. Huh. Well, that's a bit annoying. Huh. If you highlight everything and go to selection filter, you can turn slab area off and highlight only these springs. Then go to the properties and then fixed in as edge rotation. If I fix everything, completely fix it, rerun it. Okay, so since I've been skimming through, I'm not exactly sure why that causes problems, but it appears to have run now. And as you can see, it has exported some information. So as far as my ground bearing slab, this is obviously very unrealistic, but just for the sake of a demonstration, this is the sort of thing that you would be exporting then when you run the analysis, when you go into the reaction plans, which if we look down this combination list here, is what you find here. Max reactions, standard reactions, minimum reactions. That's what you find within typical. This is because when we were going into low combination criteria, we selected reactions, soil bearing, and slab stresses. As I was saying before, it's very useful, these two options at the top here, to change the size of the text, because once you start analysing the slab correctly, once all the reinforcements in and you're looking for shear stresses, it gets very congested and it's very hard to read when there's numbers absolutely everywhere, so these are very useful to use. If I go up here again to the visibility options, well, not the visibility options, but the contour options, which is this, the plot, we can now plot the sort of forces and reactions we want. So even though I have the reactions plot up, I can in fact select what I want to appear just by looking through these tabs here. So if I want to turn off the reactions, I'll just do that. And if I want to look at, say, the slab stresses, forces even, I can activate that and highlight, say the moment at the midpoint in a y-axis. And if I want that to be on, so I can select any of the low combinations if I want that for the ULS case. I'll do it again, highlight this and press OK. Then it will give me a contour with the various numbers for the moments that is present within this slab. On the right here, you can also get a better understanding moment for shear and axial. But if you just click this, since moments already appeared, selected and being displayed, if I just cut a section across here, that'll tell me exactly the moment as it goes across. So obviously there's a number 5 here, 5.5, but because I cut a section through here, you can actually see that right in the middle here, it's about 6.37 is our maximum bending moment that we're getting there. This is very useful. Following that, there's actually other contour options that you can cover. So I don't actually really like this one when I'm modelling. I usually go for colour contour, and that one just gives it's a lot easier to display the sort of thing that you're actually looking at. It gives a better context, I think. Okay, so just based on this alone, you could get a fair amount of design data out of it, I believe. But really the real meat of this software is when you get to the next stage, following analysis, where you want to look at the actual design. And that is when we get into this section here under design strips. Now this is a different plot entirely to most of the softwares I've used. Along this side then you have various construction lines again, but you have spans and boundary lines. This is basically how you would design your column strips and your beam strips and all of that sort of thing. So luckily for this particular case, it's not very complicated. It's just a very uniform shape, no complex geometry, no columns appearing. But if you had a case where, if I go back to the mesh and I place a couple of columns here, here, and here. Actually, let's just make them some square columns. Can we do that? Where are the square columns? I must be forgetting something. Never mind. For the sake of argument, if we just stick these in here, and then we generate a mesh. Now we go back to, well, if we first check the element, see if they've actually appeared. Yes, they have. Then if we were going into our design strips, we would effectively have to map these sections, these segments, the spans, across them, and have them sort of do this sort of thing, and then have boundaries to stop each design strip spilling into one another. I'm not explaining that very well. If I go onto the, where is it? These are the boundaries. Okay, so if I go on a boundary and I draw a boundary line there, enter. I cut that off there. And then if I want to see what these two look like, what I would do is click down here, generate selection strips, and that'll show me the area that it's projecting. This is going to cause problems again though, because as you can see here, it's spilling outside of the geometry. It always has to stay within the geometry. So what I would do is place a boundary line across the outside perimeter of the structural geometry to make sure it's always within here, because these design segments, is that what they're called? Is that what they're called? Just trying to highlight it. Yeah, span segments. Span segments are what is then used in the design analysis stepping to give you your results. And when you go to display these results across the slab to get the slab forces, it will just give you whatever shear and bending is within each span. So effectively they're like beam strips, and it will design it like beams. Within the options for these span sections and segments, even if you double click that, you've got a lot of options. You've got strip generation, how they're going to do that, whether it's automatic, full width, code, T-beam, useful if you're modeling downstand beams. As I was saying before, you want to incorporate the soffit, the slab, as the flange for the beam. Typically though, I always leave full width on, and I typically put manual just because it gives you greater control over modeling the complexity of the spans, so that you don't it doesn't cause as many problems if you're just sketching out the way that I do. And I always typically select this option here, which says the middle strip uses the column strip properties. There's no difference. I'm sure there's some situations where you would need to differentiate the two. I just haven't came across them yet, but within here then, this will give you your design criteria that you'll use. So within here then, you'll be able to tell the software what top bars you're using, what bottom bars you're using, what shear bars, cover, etc. And that's what it will use then to actually model the reinforcement in the next section, which is within here, reinforcement, and within these detailed perspectives. These two are key folders that talk to each other. So if I back out of this, just a note actually, within the design strips then, there's a latitudinal design span plan and there's a longitudinal. In order for the software to run correctly, you need to fulfill both of them, and naturally latitudinal, you draw your design segments, span segments horizontally, and then longitudinal design span, obviously you do the opposite, you do it longitudinally, and that's how you do your design strips correctly. So if I back out of this then, and I then go into the reinforcement plans, once again, more plans. You have a standard plan, top bars plan, bottom bars, shear bars, latitudinal, longitudinal, etc. If I just go into the top bar plan now, and I want to detail the top reinforcement for this element that we've got here. Actually, before we do that, I'm just going to go into the mesh and delete these columns because they're ridiculous. Okay, get rid of that. Wicked. Once again, got to generate the mesh again, otherwise it won't know what you're doing. Back out of that, come back into here, and this is our reinforcement. Again, I'm just going to close these folders. So, new options down the right hand side then. So, for this, you have concentrated bars, like if you're trying to top up layers, and you can, I'm not quite sure what the difference between these two is. And then there's this, which is again a concentrated amount of bars, but it's over an area. So, well, if I just draw this, so that will come up. That error then will come up if you don't have the correct layer selected. So because we're in the top bars plan, if I hold down the right mouse and go to selection properties, and we see here for this selection of the bar, it's actually got the bottom cover. So that's why it's not appeared, because we're not on the right menu for it. So if I change that now to top cover, it will appear again, and there we have it. So as you can see here, it's one bar, and you can specify how, the span that it covers, or you can go into the menu and automatically manually do it by choosing the length and then the zone width. So if I want that to be 2 meters, it will spread over 2 meters. If I just click on these and change these to cover quick, I think there's not that much different with that. Okay, it's just a different way of modeling it, and then obviously this one, I think it goes in 2 directions. Top cover, yeah, so that covers omnidirectional. Okay, but because this is a raft, we'll just cover the whole area with the same bars. So if we click on this one then, which is distributed reinforcement across the perimeter, then we go top cover, and we put, I don't know, 35. This is very useful to know. If you don't correctly anchor the bars within your slab, i.e. at the corners, putting 90-degree hooks in, that sort of thing, which in this case, if it was a pile cap or something, you would place 90-degree hooks in so that it can lap onto the bottom reinforcement and anchor itself in. But a very I'm not sure if it's a bit of a cheat way of doing it though. What I typically do is just click on anchored, and it basically assumes that all of the reinforcement that you're placing in here has headed terminators on the end of it, and therefore it develops the anchorage length automatically. Yeah, if you're doing advanced detailing where you're trying to work out whether the bars have got enough anchorage, if they're lapping around corners and stuff, I probably wouldn't recommend that, but for most of the cases that I've used, I find this is useful enough. So yeah, I'll go ahead with this bar type. I'll select H16s and I'll put them at 200mm spacings, and I am going to then right in the middle, select across the whole area, and automatically it knows where the perimeter is and it sticks it in. Bosh, done. So then if I open up my bottom bars plan, and I effectively do the same thing then, which is I go bottom cover 35 anchored. Ooh, did that do it in both latitude and longitude? I'm not sure actually. I think it does. H16 200, yeah, let's do it again. So click on that, and there you go. So that should have it in both directions actually, I hope. We'll see then. So following that then, if I go back into our design strips, because otherwise it won't know exactly where to place these bars, and actually I have a feeling that because it is such simple geometry it will automatically know where to place them, but for the sake of argument, if I just place some design strips across here in a latitudinal direction, well actually the method I usually take, saves me a lot of time usually, is draw the boundaries first. It makes things a lot easier I find, especially since the manual options are turned on here. Actually no, not full width, I'm put that as manual as well. I usually put manual, column, middle strip same as column strip. Okay, so if now we go within here and just draw the boundaries in first, it saves a hell of a lot of time down the line, because problem is if these aren't in the exact right places then it'll spill out everywhere and it will cause problems, so it's just better to do it this way. And if I just draw one between there, the difference between simple use of RAM and advanced use of RAM is really to do with how good you are at drawing design strips, I find, because it just opens the opportunities up really. Actually I'm going to put orthographic on so that we can actually get them in the right places. If I just draw span segments like that for now, should be good enough. And then instead of selecting each individual one, if I go up to the top left here, I think it's this one, and generate strips, and it automatically does it. As you can see, some areas aren't filled in very well, so what you would do then is play around a bit and try and get as much of the space hatched in as possible, because wherever there are gaps, that's where it's not being able to analyse it properly, so that can cause issues if there are just areas that don't have any structural support, because if there's a gap, there's no reinforcement going through it basically. So if you go into the detailing later on and see the bars that are missing in areas, it's probably to do with this. So if you open up longitudinal design spans, and we just place again some boundaries in, let's go orthographic again, and we do top to bottom, basic, and we just keep it like that actually, and we just draw some spans, nice like that. Then it should be fine if we click on that. I don't know why it's done that exactly, that's not great. Maybe if I draw the boundary around the outside of this first. if I delete these two and instead I split this up a bit more. Oh. Actually, if I go through that and segment it up a bit more like this, therefore the spans will be a bit shorter and should be able to fill out, oh bloody hell, fill out a bit better. There we go. And if we just click again on this, there we go, we've got something that looks a bit better. If we close these down then, and we move on to the next stage, then if we go back up here to calculations, and we do again calc partial, and we go to the, not the design actually, it'd be the detailing stage, because it's actually gonna, since we placed the bars in, it's gonna detail it correctly. And it'll actually produce a reinforcement plan. So let's come up with a couple of errors here. Hopefully that doesn't ruin the way this detailed the reinforcement though. So if we go into reinforcement here, at the very bottom there's an option for detail bars and transparent slab. So if I click on this, it should hopefully show us our bars. There we are. So that's the beauty of it. You can see whatever you've modelled in and pick up on any errors within this. That's just showing it at the surface level. This is the entire structural slab element and exactly where the bars are in with the correct cover. And sorry, following this then, if we back out of this and this, and we go then into if we go into design status, look at the status plan, it's showing that everything's looking okay, but if we then go within this contour again, basically what the status plan within the design status section covers is whatever you've placed in with the bars. It'll tell you if it's working correctly, and if you select different load cases within the contour option, the plot, you can then do a actual section analysis on it. So if we go into the plot again and we select the ULS case, oh, okay, maybe not for that then. Oh yes, of course. So on top of all these, earlier when we selected the loan combinations, we also selected active design rules, and so for the ULS we had strength, accidental and ductility. So if I select strength design, then that will give me the option for section designer, and so if I then activate that and I go to check on the top reinforcement and I select without span detailing, then this will tell me if there's any additional reinforcement requirements. Because it's saying all 0, that's fine, looks like it's great. This is typically shown in a millimetres squared, so what it's showing there is actually 0 millimetres squared required of additional area steel. If it was a case that there was a requirement for additional reinforcement within these spans, it would show a number, probably 100, 1,000 millimeters squared, whatever, and that's the way you check that. I don't recommend the punching analysis. I don't think it's as accurate as it could be, and I haven't used it all that much. But this is the general gist of what you would export in the end. Following that though, down the right hand side here you have audits. So within this then if you highlight this, and what this is showing here, and the reason why design strips are so important, is what it's tallying up here is within the design strip, based on the loads that it's perceiving, whether that particular strip can take it. So if we click on this will show us the complete audit, the report of the design and the loads going through this exact strip here. So it's quite finicky to read, but within here it will tell you the exact strip that it's referring to, the depth and the width, the grade of the concrete, all the properties, the type of steel that's in it, the top and bottom layers, whether it's developed, how much of it's developed, and then all that stuff. And then below that it will follow 3 design iteration passes, and whether it's picked up anything within each one of these passes. So it goes through the design rules that we've picked earlier, and so no failures have been picked up within that, and that's the reason it's demonstrating this. So that is your design. Other than that though, if we go back into design strips, if you wanted to get a deeper understanding of the actual forces, the moments, shear force that's going on within the slab, you wouldn't look within the load combinations, you'd look in the design strips, because if I want to know exactly what's going on in this middle portion here, for example, I've got a design strip going straight through the middle of it, and that'll tell me exactly what's going on based on like a beam analysis. So if I go up to the top here and click on plot results, and I go down to the ULS condition, and I select strip, and I activate it, and I go over for the bending, say, and I want a maximum moment for the bending, and I click OK. That'll give me all of these internal moments within each strip. Again, if we reduce the text, then I can pick up that within this middle portion here, within this design strip, that we've actually got a peak moment of 16.1 kilonewton meters. And you can do this for all the different internal forces, and it's you've got deflection at the bottom here. You can see the check for that as well, and it just becomes very useful for certain specifically accurate areas of the slab. It's a lot better for highlighting specific regions than the big plots that you get with the low combinations. Say for these maximum bending plots, you can read contours off it and get a generalized understanding of moments, but that just gives you a much better understanding. And if you're say designing an upstand within this, so say if this strip here was effectively an upstand, then I could go in here and I could select vertical shear maximum, and then this would be the sort of forces I would then be looking to design my upstands for. So I think I've covered just about everything. I hope you learned something, and yeah, good luck using RAM.